Yes, sir.
Please share your transcripts with in the final report.
Sure, sir. I will do that. Yeah.
Yep.
Thank you.
Thank you. I think so. Only one Satyajit is remaining from my students, and then we will move to Professor Gupta's student. Satyajit,
Yes, sir. Yes, sir.
yeah,
Sorry.
please stick to the time and only focus on the comparison of the explainable AI without
Okay,
the
sir. Oh, okay, sir. So, is my screen visible, sir?
yes.
Okay, so my topic is online shoppers purchasing intention using explainable AI. So this is my data set I have taken from Kaggle. So there are 16 features and one target variable, that is revenue. So these are the descriptions of different features, and for example, where I have used revenue as a purchasing intentions for analysis purpose. So coming justification of the research, because a lot of time this as ML and DL are maturing, so a lot of companies are using this machine learning, deep learning algorithms. For example, in banking sectors as well as in finance sectors, they are trying to coming up with AI systems which can accept and reject the loan. So explainable AI can play a big role in why part, because why some loans are being rejected. So same case can be applied in e-commerce industry, where there is a need for transparency and trust for end users. That is why this research is very much required. So coming to this explainable AI, I think this is self-explanatory part. So for example, when coming to visual number 2, interpretability versus accuracy. So there are two models. For example, random forest and neural networks. They are the black box models. So they are less interpretable, but they are more accurate. But the point is that but most of the industry, they need more interpretable model, and so that they can explain the outputs which are coming from the black box model to the end users. For example, in the first figure, if we are training any a computer vision model, for example, and we have inputted data to the black box model, and we are saying that this is a butterfly, let's say. So but why we are saying this is a butterfly, there should be some explanation. So once we put explainable AI layer after the results, so this is called a post hoc analysis. We are trying to interpret the result using the explainable AI layer. So that is why we require this explainable AI thing. So coming to this methods, so I have used two methods. One is line and another one is SAP. So line is basically, it's a local interpretable model agnostic, means it can interpret any machine learning models, ML models. So that is why they are model agnostics. So for example, there are two features. So I have used, let's say, visitor type and bounce rate. There are two features, and we have developed different decision boundaries. For example, this is a non-linear decision boundaries, and blue and let's say dark blue, those two are the class. One is purchasing intentions and other is they are showing non-purchasing intentions. For example, this is a new customers, new visitors, and we are trying to figure out, we are trying to predict whether he is going to purchase anything from our e-commerce platform or not. So for that, we are trying to develop a local interpretable explanations for this, and then trying to coming up with this explanation. So local interpretability means we are trying to explain by using the surrogate models for a new unseen customers. So this is a line. So the visual 2, the figure 2 shows our Python code. So 0 and 1. 0 means no purchasing intention. So the reason for no purchasing intention is, let's say, the page values, information durations, how much time they have used this websites, product related informations, exit rate. So these are the factors which are contributing towards the non-purchasing intentions, and one is a purchasing intention. So these are the factors which are responsible for making any customers for their purchasing intentions. So this is line. Second one is a SAP. SAP is basically Shapley additive explanation. So SAP typically use game theory. In the first visual, for example, team. Let's say team, there are different members. So and game they are trying to play a game. Let's say it's a Kaggle competitions. So when they are contributing, let's say they stood first. So in that case, there are different contributions of these three players. So let's say this blue player has a higher contribution. So if you remove this player, so they can stand second. So but we don't know how they have contributed it. So we cannot equally divide the prize money. So there is a need for this SAP value. So in the SAP value, teams are basically, these are the features, and the black box model is the rule of the games. So based on these, the SAP values, they try to compare the contribution of each variables, and then they decides the predictions. So this is how SAP typically works for predictions. So the key findings in my case, so key finding in my case is I have used three different interpretable techniques: line, SAP, and ELI5. Also used for Python. It's a Python library. So these three techniques I have used, and two methods, two black box methods. One is ANN, artificial neural network, and second one is a random forest. But when I and I have tried to pick up the 5 different features which are very much important for a customer's number, let's say visitor number 50. So these are the factors for visitor number 50. They are showing no purchasing intention, and we are trying to measure why they are showing no purchasing intention. So factors are visitor types, special day, bounce rate, operating system, browsers. Similarly for ANN, it is the page value, bounce rate, product related. So these are the some factors. And also in ELFI, they give us some contributions. So 0.0627, these are the bias terms. Page value, these are the contributions. So I have shown it in this reverse order. These are the contributions of different factors which are responsible for making any visitors whether they want to purchase some product from e-commerce site or not. So this is how my key findings are, and the business implications for this. Once we have developed the AI systems.
This is not needed, Satyajit. This will remain the same for all of these, right? But you tell me, how will you now compare random forest and ANN? In both of these, the parameters coming out for explainable AI are very different.
Yeah, because they are learning patterns differently. ANN will learn patterns differently, and random forest will learn different patterns differently.
No, I meant, sorry, in the random forest, if you look at lime and sharp, both of them are giving you different parameters.
Yes, sir.
Now, what about the accuracy of each of them? Which is more accurate?
I think, sir, as per my understanding, sir, if you say, so lime and sharp both are for the local interpretation. So we have to compare different factors as per my understanding, because there are slight differences.
We are comparing different factors. I'm saying, what is the accuracy of lime model?
Lime model, sir, I can show the the code accuracy. If you can see the accuracy, sir, here. These are the some, sir, accuracy part here, sir. They are able to predict the 196 columns.
Visibility confusion matrix.
Yes, sir. Using the confusion matrix only. And typically, sir, lime gives us some of the factors which are prominent, means these all are the factors. If you can list out the top 5 factors which are contributing towards non-purchasing intentions.
वो तो ठीक है, मैं ये बोल रहा हूँ कि देखो same model के लिए your two methods are giving two different results.
Yes, sir.
Correct. Now which one to take?
So depending on, as per my understanding, we will go with the SAP value, because they are based on game theory. So they also compare different features. So as per my understanding, we should go with the SAP.
Why not ELI5?
ELI5, because these are the weak models as per my understanding, as I have read in the research paper. ELI5 is a weak model, basically, sir. It's a weak.
Okay. Okay, okay, Satyajit. Thank you.
Thank you so much, sir.
नहीं इसमें